It's August the 6th, 2020, and welcome to the Water Action Platform. My name's Piers Clark, and I'm the chairman of the ISLE Group. We're an independent technical consultancy that works with water utilities all around the world. This week, alongside the usual updates from the various WhatsApp knowledge hubs, our sector experts section includes an update on the WBE program in South Africa and our showcase technology as a process that dries sludge by freezing it. And at the very end, there is arguably the cutest COVID-19 story that you will ever hear. It promises to be a great session. If you want to make a comment or raise a question, please open the chat function by clicking on the purple triangle to the right of your screen. This webinar is being live streamed, and at the end, we'll do some Q&A. So let's jump straight in with a story which was shared on our Knowledge Hub for Sustainable Development Goals. It began with a question. How do you get the world to notice that we're running out of clean water? Many of us, I'm sure, know the facts presented here all too well. 2 billion people lack access to clean water. Many more lack access to safe sanitation. By 2045, it's predicted that we will not have enough water to meet our needs. How do we get the world to notice or care about this issue? Answer, by pointing out the threat and relating it to something that arguably all of us are united around: football. Xylem and Manchester City have teamed up to create a short film called The End of Football. The film highlights the fact that if our complacency around water continues, we are just one generation away from water scarcity touching every aspect of our lives. Interestingly, this film was made before the pandemic occurred, i.e. before COVID-19 actually stopped football matches happening. The coronavirus has shown us just how fragile the world and its favourite sport really is. Now, that introduction serves as a lovely segue into this study undertaken by the Stockholm International Water Institute and UNICEF. They mapped what has been happening in Latin America in relation to WASH, water, sanitation and hygiene. They were looking to see how things had changed during COVID-19. This map shows the findings. Red is bad, dark green is good. At first glance, the map looks encouraging. However, the authors concluded that as the pandemic response moves from lockdown to de-escalation to recovery, governments' priorities are shifting. A key message from this study is that access to WASH services is losing centrality in the debates. It risks getting lost in the discussions about economic revival. Now, that's perhaps understandable. Service providers are finding it increasingly difficult to meet their operational costs. It might be understandable, but that doesn't mean it's excusable. Similarly, there's this report from WaterAid and the End Water Poverty. It predicts that low and middle income countries will, on conservative estimates, have $396 billion less to spend this year. The report includes some recommendations, but they make for challenging reading. For example, they propose an increase in aid from governments of higher income countries, raising it from 0.7% gross national income to 1%. Staying with WASH, but moving now to North America, one of those higher income countries, we have this article from Circle of Blue. It reports on the indigenous people living in the United States and highlights how COVID-19 is hitting them particularly bad, since many tribe members don't have access to clean water in their own homes. To be honest, for these communities, the primary problem is access to safe drinking water. COVID-19 is a secondary problem. There is a glimmer of hope. The article reports on the Navajo Water Project, founded in 2014 by Dig Deep. This project brings running water to Navajo families across the USA. Hence, this lovely picture of a parent bathing their child in a sink with newly installed running water. But before we get too encouraged by that small glimmer of hope, I've got more bad news to share. It's becoming clear that the COVID-19 water challenge isn't just about the supply for domestic consumption. This report from the World Food Programme highlights the impact COVID-19 is having on the food chain. It focuses on India, one of the world's largest food producers, and somewhat ironically, also the country that has 1/3 of the world's malnourished children. This report shows how the virus has disrupted global and local food systems. It predicts that the number of people facing acute food insecurity globally will more than double this year to 265 million as a direct result of COVID-19. So, is it a water issue or a food issue? Well, it's both, and they are inextricably linked. This report by Mubdumbi et al. Looks specifically at South Africa, but it exemplifies a global trend. The top graph shows the number of water-dependent jobs. Take-home message is that 3 million jobs in South Africa are highly and directly dependent on water. That's 15% of the working population. The bottom left graph shows water use by sector, with agriculture dominating at 67% and domestic use at 18%. The bottom right graph shows the financial value of water sales by those same sectors. Note that agriculture drops to 2% and municipal rises to 58%. What does this tell us? It highlights just how dependent food security is on water. It also shows how much that important link is overlooked and commercially undervalued. Interestingly, and we all know I love to find these glimmers of hope in these reports, it concludes that for every $1 spent by governments on water infrastructure, $6 of private sector investment is created in the local economies. So there's your answer. Whether we want to solve the wash problem or the food security problem, the answer's the same. We have to invest more in water infrastructure. That is, of course, terribly easy to say and much harder to deliver in practice. Look at this example from Bolivia, highlighted by Ronaldo Hinojosa, chairman of the National Federation for Water Cooperatives. Rolando recently stated that 160 of those water cooperatives were essentially insolvent. They were told to halve their bills during the pandemic on a promise from the Bolivian government that they would make up the difference. And so far, at least, it's not happened. The same point has been highlighted here in a recent GWI article. Their conclusion is that the most vulnerable utilities are the small ones who, irrespective of the country they are in, developed, developing or emerging, the utilities that are serving low-income communities. This quote from Luke Wilson, Deputy Director for the Centre for Water Security and Cooperation, sums it up perfectly. Utilities are being forced to take on debt by the government, but people may not be able to repay it, and the government may not be able to backstop the utility. We are walking on a knife edge. With all that bad news, it begs the question, how can we move forward? Well, I suggest there are three things we can do. Firstly, we must openly and honestly acknowledge the situation so we can start a dialogue about the situation. Fortunately, there are multiple forums where this is being done, including this very webinar. On this slide, we reference the forthcoming GWOPA webinar, catchily entitled "There's a Hole in My Bucket," which specifically addresses the liquidity challenge. Secondly, we should wholeheartedly embrace the digital revolution. A number of sources have identified that one of the key positive impacts of COVID-19 will be a greater shift to digital. This has been a topic on our Digital and AI Knowledge Hub. Indeed, James Boswell, a director at Centrica, recently stated that COVID-19 pandemic had resulted in 5 years' worth of digital change occurring within just a few months. This could be transformational for the water sector. We've known for years that if we used our data more intelligently, we could make more informed capital and operational decisions. But it's difficult moving legacy systems to a new digital way of working. Perhaps COVID-19 will provide the impetus we need. And finally, there's the role of new technology. The water sector has no shortage of great innovative solutions, promising lower costs and better quality services. As a sector, we are not short of new technology. However, when compared with other sectors, the water sector is often described as conservative, slow to adopt. We're accused of undertaking endless trials or doing trials at too small a scale, or perhaps worst of all, doing a successful trial, proving the technology, but still not quite managing to get our organizations to adopt said solution as business as usual. With this in mind, the next webinar will have a particular focus on technology. Next time, my colleague Matt Stevenson will provide a summary of the highlights from the COVID-19 tech scan that we recently completed with the support of 20 or so Water Action Platform members. Moving now to one of our regular topics, transmission. In the last week, there have been some developments in the thinking around mode of transmission, in particular relating to social distancing and also relevant to this audience, whether sewage represents a source of transmission. On the Water Action Platform website, there's a short video update from our resident microbiology expert, Dr. Joe Burgess. And in summary, there are two key things that you need to know. Firstly, that there is increasing evidence that 2-meter distancing is insufficient when you are in poorly ventilated areas or areas with high footfall. Secondly, that while the fecal transmission route is still not proven, there is now firm evidence that it is at least viable in theory. Transmission direct from one infected individual's urine is, of course, a long way away from meaning that raw sewage is a transmission vector, but it's something of which we all need to be aware. Moving now from transmission to surveillance, another topic which has come up in literally every one of these webinars. As the various global research teams beaver away on their studies, we're beginning to see some really interesting results. CSIRO in Australia believe they now have a cost-effective, rapid and accurate system for detecting SARS-CoV-2 RNA. They claim they can pinpoint infected passengers on planes and cruise ships. Looking now at data from a different research group, KWR in the Netherlands, they were one of the first to launch a sewage surveillance program, and they've been monitoring SARS-CoV-2 RNA in 10 cities in the Netherlands since late February. Dragan Savage, the CEO for KWR, shared their work on one of our first sector expert interviews back when we were just starting these webinars. 5 months on, KWR have published some new data presented here. Note, the latest data point is from July the 29th, last week. KWR have established graphs for several cities. Here's the one for Utrecht. The curve correlates with the number of registered cases in hospital admissions. It is striking that the sewage water curve, the orange line, reacts about a week or so before the hospital admissions. Now, this isn't surprising. People infected with the coronavirus have no symptoms on the first few days, but they do excrete the inactive RNA into the sewers. Looking now at this graph for Amsterdam, not Utrecht, you can see clearly the start of the second wave. Note how the orange line steadily increases from the middle of June to the middle of July, followed 2 weeks later by a clear rise in the reported new cases in hospital admissions. However, there is an important difference between the first and second waves. In the first, the virus wasn't present at all beforehand, yet for the second, we've got a residual concentration of RNA that's still present. This is why monitoring the changes in the concentration, rather than simply the absence or presence, is crucially important. As we discussed many times previously, these examples highlight how sewers can be used as early warning systems. Staying with the topic of wastewater-based epidemiology, we now come to this week's sector expert. And this week we have two of them, Dr. Kalebaila and Mr. Bhagwan, both from the Water Research Commission of South Africa. Now, we've talked about South Africa many times on these webinars. Back in April, we commented on how South Africa appeared able to apply to this pandemic the learnings it had gained from having a 1 in 50-year drought for 4 consecutive years. Furthermore, South Africa is a middle-income country that has recently launched its own national wastewater-based epidemiology program for COVID-19. What people often forget is that South Africa already had a WBE program and contact tracing programs in place in order to monitor for other viruses, Ebola and polio. Perhaps their drought experience, coupled with the pre-existence of WBE programs, helps explain why the COVID-19 case numbers stand at 500,000 in South Africa, but the deaths are only 8,000. By comparison, the UK, a country of broadly similar population size, has 300,000 cases, but 46,000 deaths, 8 times as many. The Water Research Commission is a unique organisation, part multidisciplinary science council, part government advisor, part innovation incubator. It's funded and constructed the SARS-CoV-2 programme, and here is Mr. Bhagwan from the Water Research Commission giving an overview of that programme.
You know, what we did is that we needed to be very strategic on how we engage this at a national level. So we established a stage gate approach, or we called a phase approach, and we divided our initiative into 3 phases. And the first was to do a proof of concept, okay? And that is very important for us. So that the 3 phases was start the proof of concept, organize for a large-scale demonstrator or pilot, where we could then start feeding the national systems with good information and data around the hotspots and the trends, and then work with government of scaling this up right throughout the country.
The principles adopted in South Africa are similar to what we've seen elsewhere, namely the EU Sentinel Cities Initiative and the Australian Monitoring Programme. However, South Africa differs from high-income countries in a couple of key ways. Firstly, South Africa has to include informal settlements being served by communal ablution blocks. That's buildings with toilets and showers and laundry facilities that are used by the surrounding community. And secondly, South Africa has, so far at least, managed to suppress the first wave of the pandemic. The first major peak is now predicted to occur within the next 3 to 5 weeks, and this provides a unique surveillance opportunity. We can trace how the readings will change on that all-important upslope of cases. Here is Dr. Kalebaila, who is running the program, describing the results obtained so far.
So far, we've already kick-started with the phase 1 of the national program, which really is a proof of concept study. So in the proof of concept study, the whole aim was to really test the feasibility of implementing a full-scale program. So from the results that we have so far, which are basically from samples that have been taken over a couple of weeks in a number of hotspot areas around the country. So we have consistently detected a viral RNA in all the samples that have been taken so far. And we've also started doing some trends using the results that have been obtained. And we're already seeing some increases, which coincides nicely with the peak period that we are in.
South Africa will soon have the ability to cross-reference and review the goodness of fit of its WBE data with the epidemiological model, and with the actual patient and fatality numbers in a few months' time. We will closely monitor what is happening in South Africa and report back to you on any significant developments. The previous clips were taken from an interview between Dr. Jo Burgess and her former WRC colleagues. Jo used to work there. The full interview is available on the Water Action Platform website. And now we come to this week's Technology Showcase. It's something completely different. This week's Technology Showcase is a process to dewater and dry sludges by freeze drying them. The company behind this rather wonderful idea is Elajo from Sweden. Elajo has been around since 1958 and is one of Sweden's leading mechanical engineering companies. As usual, this showcase comes with the caveat that ISLE has no commercial ties with the company. We identified them through our long-running technology approval group forums, which I won't discuss here. I suspect about half of this audience, the half involved in drinking water rather than wastewater, might find the next 3 minutes superfluous. But I encourage you to stick with it, because whether you're a wastewater sludge person or not, this is a fascinating technology. The freeze-dry process that Elago has developed is a completely new way of dewatering. It works with any sludge or slurry with high water content. The process is based on advanced temperature control. It's energy efficient and does not use chemicals. Now, currently, most sewage sludge is mechanically and chemically dewatered, usually to a dry solids content of around 20 to 30%, meaning there's 70 to 80% is still water. That relatively high water content in dewatered sludge poses several problems, not least because when you're transporting the sludge, it means the weight of water, a lot of the weight you're carrying is just water. There are already many technologies for drying sludge to a higher dry solids content, but these are typically high temperature processes which use a lot of energy. The trick that Elago uses with freeze dry, as the name suggests, is to incorporate a low temperature sludge freezing stage. Freezing the sludge frees the water trapped in the sludge solids, making it easier to evaporate in a subsequent high temperature stage. Also, the mechanism used to cool the sludge generates waste heat, much like your refrigerator does or your air conditioning unit. In the freeze dry process, the waste heat is captured and reused in the later high temperature stage. This step in the freeze dry is key to their energy efficiency. Also, usually dewatering processes require considerable amounts of polymer chemicals. The freeze dry process doesn't. Here is a 2-minute clip from Stefan Ekstrand, CEO of Elago, sharing some more details.
So what happens first is that we have the sludge, and then it starts to freeze. The water starts to build up, and after the freezing process, we ended up with water and sludge. So that is now we're separate. So this is how the sludge looks like after it's been frozen. So it's separate. So now when in the first phase, when we have frozen the material, you have sludge and you have free water. And then we're starting to thaw and dry the material. The water is removed, the sludge stays in the machine. We end up with two streams of things out of the process, and this is clear water, which is particle free, and then we ended up with a sludge. So if we would follow the process a little bit, we're starting off with freezing the material, and you remember this block of ice. So after this step here, you have sludge that is frozen, it's water, and it's sludge, but it's in frozen form. So what happens in the next unit here is that we're starting to thaw the material. All the water is removed. The free water is removed. So if we would stop the process here, you have 30% dry solids. That's where we are now. So the next step is then to dry. So how far do you want to dry it? You want to dry it to 95% dryness, 60, 80, wherever you want to go. That happens in this piece here. And then in the next and the last step, you have a hydrogenation or a sterilization of the sludge, if you like to. And we have the energy consumption. It's basically 1/10 of a normal belt dryer or whatever we have. So if we're going to detailed numbers, depending on the sludge, we use 20 to 50 kilowatt hour per cubic meter or ton.
So, in summary, the freeze-dry technology could potentially replace a number of current processes typically employed at a wastewater treatment facility. Elajo claims it doesn't use chemicals and it operates at 1/10 of the usual energy consumption. If you want more details, visit their website, contact the CEO, Stefan, directly, or drop me an email. Now, I was dared by one of my colleagues to make a joke during that last section about poopsicles, but I think I got away with it. And finally, we come to a story about a global conglomerate finally admitting that they don't have all the answers. The conglomerate is Intel. Everyone knows them. Everyone knows that they do clever things with computers and big data. What you might know is what they do in water. As it happens, Intel actually do a whole bunch of stuff in water, but in a refreshing new approach, rather than letting the sector, telling the sector what they think the solutions are that you need, Intel want to listen first. Intel want to understand the challenges and business events that cause you pain. What are the big data issues that prevent you from making the best decisions for your customers? The road to digital transformation has been trodden by many utilities already with varying degrees of success. What's become clear is that the path differs for each utility. The digital transformation journey needs to be tailored to fit each utility separately, reflecting where you are today and precisely where it is you want to get to. Now, Intel are inviting you to a webinar in which the common digital challenges that water utilities face and some global case studies in digital transformation will be shared, such as Tampa Bay's Smart Water Decision System. Now, I've got to stress that this isn't your typical sales webinar. It really is about finding how best this group can work together. Following the initial session, a small elite group of curious water companies that are passionate about digital transformation and have a culture for co-creation will be formed. The initial webinar is on the 23rd of September at 3 p.m. British Standard Time, but if there's sufficient interest from people outside this time zone, an alternative date will also be proposed. It is all free. All you need is to be open to discussing your challenges in an environment where it's okay not to have all the answers. If you're interested in knowing more, add a comment in the chat box here or send Megan or me an email and we'll provide more details. Now, I know I've already done and finally, but bear with me for one more minute. The following story was so good, so perfectly cute, that when I saw it 24 hours ago, I just had to include it. This final story relates to the use of man's best friend as a low-tech method to detect COVID-19. A new paper in the BMC Infectious Diseases Journal describes how sniffer dogs have been retrained to instantly diagnose COVID-19. 8 detection dogs were trained for 1 week on the saliva and tracheobronchial secretions of SARS-CoV-2 from infected patients. The trial was randomized, double-blinded, and fully controlled, i.e., it was proper science. Astonishingly, the dogs were able to discriminate between infected and non-infected samples with an average diagnostic sensitivity of 82% and a specificity of 96%. From over 1,000 randomized samples, the dogs achieved an overall average detection rate of 94%. with only 63 incorrect indications. Without a doubt, that has to be the best story of the week. Now, with that, I bring this week's webinar to a close. I thank again our partners and sponsors for their kind and continued support. But before we finish, let's have a quick look at the chat box to see if there's any questions. Megan's been sitting here monitoring them, and she's going to just come and join me. As noted last week, Megan and I are in each other's social bubble. Megan, come and join me.
So we have one question this week, and it's about the work on pinpointing infection on planes and cruise ships. Louise has commented saying it's fascinating, but do we have any insight onto how it would work in practice?
Yeah, it's a great question. I had the same moment. I thought, well, what can you do? Actually asking the question, getting into the detail, what they can do is a very quick assessment, so that you could, on a plane, you'll know roughly who's been using the toilets at the back of the plane or the front of the plane, and it might only take half an hour to do this test. So you could imagine a scenario in the future where planes land, they do a quick test, they find that the back toilet was had someone infected, and you're then able to isolate certain people on the plane and let the others proceed. So it's that sort of methodology, which I think is quite clever if we can get down to that level of quick testing and pinpointing. No other questions?
No, but Dragon Savic at KWR has commented to say that KWR are actually embarking on monitoring local office buildings and cruise ships. And if you would like any more information, you can find it on their website.
Oh, brilliant. Thank you, Dragon. It's great to have you still with us. That's a marvelous update. So that's good. Thank you, Megan. The next webinar will be in 2 weeks' time on August the 20th. As noted earlier, we will focus next time on the highlights from the COVID-19 tech scam report. Megan will circulate a calendar invite shortly. Thank you for your time. Keep asking questions, keep sharing, and keep safe.